Hi, this is Starkey Sowers. Welcome again to another Plus Program training series. Today's topic, amino acids and proteins, and this is part one. So you might think, well, amino acids, what are they? Ultimately, amino acids are what we call the backbone, so to speak, of proteins. And so that might be a little elusive when you first think about it, but ultimately when it comes to a protein molecule, a tiny little piece of cottage cheese curd, so to speak, roughly has about 800 different amino acids all tied together. It's a lot of amino acids. They're literally like pearls on a string that's kind of tied together, molded together to form a little beadlet or a little curd, so to speak. And there's all sorts of different types of proteins and amino acids throughout the body. But ultimately, when we look at it, amino acids are the foundation or the backbones of proteins. All right, so you might be thinking, where would I find amino acids in my body? Well, ultimately, there's all sorts of different types of structural and different types of biological components of proteins. So amino acids, which make up the proteins, are part of these particular components. All right, so amino acids being the foundation. When we look at different types of proteins structurally, we look at hair, we look at skin, we look at nails, which is the outward appearance, so to speak. But the inward appearance also becomes extremely important. So when we think of bones, bones are made up of amino acids and proteins. We think of muscles, muscles are made up of amino acids and proteins. You're starting to get the drift, aren't you? Amino acids and proteins, they're synapses, they're together. Additionally, when we look at the internal mechanisms of our body as well too, when we look at cellular communication, enzymes break down foods and they're necessary for the function in each and every cell. Those are made of amino acids. So when we also look at hormones are made oftentimes of amino acids and other different types of components, but amino acids are the driving force of so many different types of hormones. So it kind of gives you an idea. Literally almost every single part in your body is made of some type of amino acid, which ultimately put together produces what we call protein components. But the focus here today is definitely on amino acids. We want to talk about amino acids, and later on what we're going to do, we're going to look a little bit about amino acids by themselves. All right, so it kind of lays a foundation. Don't forget that about 20% of your body is protein, 60% of it being water, the rest being fat and a little bit of minerals and a few other things. So a large component part of your body is protein component. All right, so amino acids specifically, when we think of amino acids, there's a couple unique things about amino acids. There's roughly about 18 different amino acids. Some authorities might say that there's 20, but for the most part, a lot of people agree that 18 would be the foundational point of amino acids. So what's critical about amino acids is this. There is what is known as an essential amino acid. There's 9 essential amino acids. So what does it mean to be essential? Well, the word essential should essentially say it all. It means that you have to have it. And believe it or not, if you don't have some of these amino acids on a regular and daily basis, your body actually has a tendency to degenerate or actually get sick. So they are essential for you to function every single day. So what about the non-essential amino acids, the other 11 or the other 12, so to speak? Those particular amino acids are essential, but the body can take the essential amino acid and make the other ones. So let's say, for instance, your body needs tyrosine, which is an amino acid that's necessary for the production of thyroxine, which is a thyroid hormone. The amino acid phenylalanine, which is an essential amino acid, the body can take that and make tyrosine. So that kind of gives you an illustration where you actually have, here's your essential amino acid, phenylalanine. The body kind of molds it, takes it, shapes it, and makes tyrosine out of it. So tyrosine being a non-essential amino acid, the body forms it from an essential amino acid. All right, so it kind of gives you an idea. Some are essential, some are non-essential. Ultimately, there's about 20 amino acids, depending on the authority that you look at, or 18, and your body has to have these on a regular basis. So you might be thinking, well, where am I going to get these amino acids? Where does my body obtain them? Well, these particular amino acids obviously come from food sources. So you wouldn't be left on the planet Earth unless you had some way to be able to obtain these things. So looking at different types of food sources, when we look at these food sources, what we notice is there's a couple different sources we can get amino acids or proteins from. We roughly need about 60 grams of proteins a day. We can get these from either an animal source or we can get it from a vegetable source. Animal sources would include things like eggs, meat, chicken, fish, fowl, turkey, as well as milk and milk dairy products, cheeses, yogurts, and all those different types of components. And those are typically one of the best sources of proteins. They have typically all the 8 essential amino acids in very abundant amounts that the human body actually does very well as far as absorbing and being able to get them into the system. So with that said, animal proteins are oftentimes one of the number one things that people will gravitate to. But a lot of you guys might be a little bit more vegetarian, a little bit more vegan, or maybe you just don't like to eat a lot of animal protein. Well, believe it or not, vegetables are a great source of proteins as well. So one thing to remember is that it doesn't matter whether you're vegan or vegetarian, you still need roughly about 60 grams or more of protein a day, especially if you're an athlete. You need roughly about 80 or even more, up to 100. So you might be thinking, well, wait a minute, where am I going to get my sources of protein from? So real quick, just a kind of simple thing that we look at, oftentimes a lot of these proteins from what we call vegetable sources are incomplete. They don't have enough of certain types of essential amino acids. So we kind of got to blend these things together. Instead of just using only one source of a vegetable protein, we want to use more of a myriad or like a variety of different sources. So some of my favorite sources are legumes. So soybeans, although not very popular, are a great source of protein, as well as other different types of legumes, such as garbanzo beans and kidney beans and things of that nature, as well as whole grains. Mixing those two together actually produce what we call a complete protein. The other thing is nuts and seeds. And when it comes to seeds, my favorite vegetarian protein is hemp. I love the way hemp tastes and I like the way it feels on my digestive system. Hemp proteins are ultimately one of the stars, so to speak, that are rising, and it's a great source of protein for a vegetarian. So as I was saying, you want to blend them together. A real simple a rule of thumb, so to speak, would be to take like maybe a cup of whole grains and maybe a half a cup of legumes and putting those together, and that will actually produce a complete protein. A lot of protein products that are on the shelves today have blended different sources together to produce what we call a complete protein. So anyways, that kind of gives us a basis of what proteins and amino acids are, gives us a difference between essential and non-essential amino acids. So we kind of have a little bit of familiarity, so to speak, of which one's what. And then what we're going to do in the next segment is we're actually going to kind of maybe expand upon some of the individual amino acids and what they're good for. So make sure you stay tuned for the next segment. This is Starkey Sowers. Thanks again for watching another Plus Program training series.